Hi everyone. So this is the quiz review for the Chapter 6 quiz, the second quiz in Chapter 6, that covers things like vertex form, the quadratic formula, and the discriminant. Make sure that you are looking at the side of your paper that just says quiz review up here at the top. The other side says quiz review homework. That's the one that you're going to do on your own after viewing this video and completing the one side with me. Okay, so consider the parabola with this equation, and it says, what is the vertex of the parabola? Well, let's keep in mind that as soon as you see that you're looking for the vertex, you should be thinking about H and K, because those are the letters that represents the coordinates of the vertex. So let's start by finding H, and I'm going to zoom in so I have a little more room here. H has its own little formula. The formula to find H is negative b over 2a. So from my equation up above, my b value is 4, so that would be negative 4 when I put it in this little formula, over 2 times my a value here would be negative 1. So that's really negative 4 over negative 2, which is just positive 2. Okay. Then to find k, I'm going to take this 2 and plug it into the equation in place of x. So when I go to find k, I'm going to do negative parentheses 2 squared. By the way, the reason I'm not including that negative sign in the parentheses is it's actually part of the equation. It's not part of the 2. So what I'm always putting in parentheses is exactly what I'm plugging into the equation. If I'm plugging in a 2, then just the 2 goes in the parentheses. So negative 2 squared plus 4 times 2 minus 3. So again, this is just this equation with 2 here and here. Okay, so that's going to be negative 4 plus 8 is positive 4 minus 3. You could just type that straight into a calculator. That was just me working through it mentally. It's going to come out to be 1. So back to the question. The question wanted to know, what is the vertex? The vertex is just h comma k, so that would be 2 comma 1. Okay. Next one says rewrite the equation in vertex form. Well, just to help us remember what vertex form looks like, it's y minus k equals a times x minus h squared. And I will give you that formula tomorrow if you need it. So now what I'm going to do is take my h value, take my k value, and plug them in here and here. So my equation would look like this. Y minus 1, because I found back here that my k value was 1, equals, a is your a value from the equation here. So my a value here is negative 1, so that's what I'm putting in here. Negative 1 times x minus my h. My h I found to be 2, so minus 2 squared. Okay, so y minus 1 equals negative 1 times x minus 2 squared. That would be your equation in vertex form. All right, question 2, same thing. So let's take a look at this one. Consider the parabola with this equation. And again, let's find h, let's find k. So start with h. H is negative b over 2a. So from my equation, my b value is negative 15. Careful, make sure you catch that that's a negative. So that is a negative 15. When I go to plug it into this equation, this negative is going to make that negative 15 turn into a positive 15. So this is going to be 15 over 2 times my a value, which is 5. Okay? And remember, if you're typing this into a calculator all at one time, you will want to make sure that bottom piece is in parentheses. So you're really doing 15 divided by 10, which is 1.5. Okay? Now to find k, I'm going to take that 1.5, put it in place of x here, put it in place of x here. So I'm going to have 5 times 1.5 squared minus 15 times 1.5 plus 9. Okay, this one I'm going to have to calculate. Could do it in my head if I really tried, but I don't want to make you sit here through all that. So 5 times. I end up with negative 2.25. So for my answer over here for what is the vertex, well, the vertex would be h comma k, so it would be 1.5 comma negative 2.25. All right, next we're going to write this in vertex form, and if you need it for reference, here's your formula up here. So I'm going to say y minus k. Well, my k value is negative 2.25, so if I'm doing y minus negative 2.25, that's really going to be a plus, equals, gosh, I might move this over, hold on. So y plus 2.25 equals, my a value is the 5 from back here in my original equation, and then x minus h is 1.5. Okay, so y plus 2.25 equals 5 times x minus 1.5 squared. Good, let's keep going. Okay, question 3, I know looks terrifying. It's not so bad. Paul hit a fly ball whose path can be described by this function, where h is the height of the ball and d is the ball's distance from home plate. Okay, so just, I want to give you a visual here. Let's see, well, let me do this. Shrink this, put it off to the side so that you can see what I'm doodling down here. So the equation that it gives you there is going to give you a parabola, and it's going to be an upside down parabola because the first number is negative. Okay, so we're hitting a baseball right here, and then this equation or this parabola tells you kind of where that ball is going to be, where D represents how far it is left to right. So this is your D value. And then H represents how high up in the air it is at that point. Okay? So if I had, I'm just going to throw a really simple coordinate out there. If I had like the coordinate 5, 3, and those are totally unrealistic numbers, but that would mean that when I'm 5 feet away from home plate, the ball is 3 feet up in the air. Okay, so this is telling you how far from home plate, this is telling you how high up in the air. Okay, so the situation is we've got a fence out here somewhere. All right, let's see, can I pick up my, there we go. I've got a fence somewhere. And we know how far away the fence is from home plate, and we know how tall the fence is, okay? And I want to know, when the ball reaches the fence, will it still be high enough in the air to go over the fence, or is it going to hit the fence and fall down? That's sort of the idea, okay? Let's see if I can get rid of that whole picture. There we go, back to our equation. So when I look at what we know about the fence is 8 feet high and 390 feet away from home plate. So the 8 feet high is like your H, and the 390 is like your D. Okay? And so I have two choices. I could either plug in the H value and then figure out how far away the ball will be from home plate when it's at that height and decide if it'll be past the fence or before the fence. Or I could plug in the D value to find out when the ball reaches the fence, how high will it be. Okay? Looking at this equation, if I plug in an H value, I'm going to have to solve for D squared and D, and that means I'm going to have to use the quadratic formula. if I plug in a D value, I can plug it in here and here, and then it's just plug and chug. Then it's just type it in your calculator and get an answer. So that's what I'm going to do, is I'm going to plug the 390 in place of D here and here. Okay, so here's what I'm going to do. I'm going to say H equals negative 0.0067 times 390 plus 2.65 times, oh, sorry, that was a 390 squared back there. I forgot that square. Plus 2.65 times 390 plus 5. Okay, and no way that's happening in my head. So let me type that into a calculator real quick. I end up with 19.43. And so here's what that means. Here's how you can interpret that. Is if 390 is my D, when the ball is 390 feet away from home plate along the ground, like if I'm measuring horizontally along the ground, when it's 390 feet away from home plate, it's going to be 19 feet in the air. Okay? So when I reach that 390 feet, that's where my fence is. Okay? So when I'm at that 390 feet, that's when I'm standing at my fence. If I'm still 19 feet in the air, that is going to be high enough to clear an 8-foot fence. So I would say, yes, it will go over the fence because the ball is about 19 feet in the air, or you could say 19 feet high, when it reaches the fence. You do have to provide an explanation, and it should be a good one, not just, yes, because my equation said so. Okay, I want to know that you understand what your equation means. If that had been a number smaller than 8, because that's how high the fence is, again, I'm taking that from here, if it had been a number smaller than 8, you would say no. Okay, so that's what your answer should look like for that one. Okay, 4 and 5, give the nature of the roots. And nature of the roots means you're using the discriminant. Okay, and then if you find out that it does have real roots, solve and find them. And solve means quadratic formula. Okay, which is related to the discriminant. So for the first one, for my discriminant, remember discriminant is found by b squared minus 4ac. So I'm going to do negative 3 squared, because my b value is negative 3, minus 4 times 1 times 130. Okay, so let's see, 9 minus 4 times 130. I end up with negative 511. Okay, my discriminant is negative. That means I have no real roots. Oops, let's do that in blue. Oh. Oh, squeezing that in there. Okay. And if you don't have any real roots, then I can't solve for them, right? So you don't have to do part B, because the question says if the equation has real roots, and we just found that it doesn't have real roots. Okay? So let's look at the second one. Now, the problem with the second one is it's not in standard form. So before we can start, we either have to move this to this side, or we have to move both of these over to this side. Okay? So I'm going to move the r squared to the other side, because it's just easier to move one thing than two. Minus r squared minus r squared. And so now my equation is going to say 0 equals negative r squared plus 2r plus 3. And now this is what I'm going to use for finding my discriminant and my roots. So for my discriminant, I'm going to do 2 squared minus 4 times negative 1 times 3. And that comes out to be, let's see, 4 plus 12, so that's going to be 16. So because that's positive, okay, when I have a positive discriminant, that means I'm going to have 2 real roots. I guess really all I care about is that you know there's 2 roots. Okay, so I'm going to have 2 real roots, and that means I can go ahead and find them. And to find them, I'm going to use the quadratic formula. So remember, here's your quadratic formula. And so when I go to plug into this, let's see, my b value up here is 2, so I'm going to say negative 2 plus or minus the square root of. Now the nice part is, I already figured this piece out. I already figured that the b squared minus 4ac was equal to 16. Okay, so I can just plug a 16 straight in there, all over 2 times my a value, which is negative 1. From here, this is not usually how I write this out, but because I'm short on space. So I'm going to have negative 2 plus this, I'm sorry, I meant to do the square root of 16 there. Negative 2 plus 4, because the square root of 16 is 4, over negative 2, and negative 2 minus 4 over negative 2. Again, that 4 came from, I just did the square root of 16 and got 4 and negative 4. Okay? So, negative 2 plus 4, whoa, didn't mean to do that. Negative 2 plus 4 is positive 2, and 2 over negative 2 is negative 1. Negative 2 minus 4 is negative 6, and negative 6 over negative 2 is positive 3. So my 2 roots are negative 1 and 3. Whoops, and I actually almost did that the way I don't want you to do it. Okay. Your roots, remember those are 2 separate equations, because what those really represent are the places where your parabola crosses the x-axis. So this parabola is going to look something like this, where it crosses at negative 1 and positive 3. Don't write them as a coordinate. You don't want to say like negative 1 comma 3, because that makes it look like it's one coordinate. Okay, so don't do it that way. You want to show that it's 2 separate numbers and 2 separate points. Okay, so now having seen that, I'd like you to go try the other side of this assignment on your own, because that's going to be very similar to what you see on your quiz tomorrow. And we'll take questions on that other side, and we will check answers in class tomorrow.